What is sensible and latent heat? Let me explain the sensible and latent heat through this graph. This graph is between temperature and enthalpy. When the heat is supplied to water, its temperature increases. Or when we uh, remove the heat from water, the temperature decreases. Uh, when there is an increase in temperature of water or any other substance, that heat will represent sensible heat. However, for latent heat, there is no increase in temperature. The temperature remains constant with the addition of extra heat. This is because the extra heat supplied is used for conversion of one state to another state. For example, here at 0 degree centigrade, ice is converted to water. So this is latent heat. During this period when ice is converted into water, the temperature will remain constant. Then after this, the increase there will be an increase in temperature with the addition of heat up to 100 degree centigrade. When 100 degree will reach, there the temperature of the water will remain again constant because there will be a phase change from water to vapor, and then again the temperature of steam can be further increased. So when we supply heat to any substance, there are two types of uh, heats. One is sensible heat and one is the latent heat, and which can be calculated through these formulas given. Sensible heat is equivalent mass into specific heat into change in temperature. Similarly, latent heat QL is equal to mass into latent heat of fusion. There are many applications found for calculating the sensible and latent heat. For example, in freezing, in refrigeration, in drying, in steaming. Let's find out how this can be calculated. The question is 10 kg of ice at -5 degrees centigrade is used to cool the vegetables for 24 hours. The temperature of ice increased to 10 degrees centigrade. Calculate the average rate of cooling in kilowatt. Here we have given specific heat of ice is this, specific heat of water is this, and heat of fusion uh, the from ice to water is 335 kilojoule per kg Kelvin. Let us understood the process which occurred in 24 hours. The temperature of ice was -5 degrees centigrade, and then this temperature increased to 0 degrees centigrade. And this is sensible. This represents a sensible heat of ice, and this will be equivalent to, for example, Q1 equivalent to 10 kg. 10 kg is the total ice into the specific heat and the change in temperature, and it is equal to 97 kilojoule per Kelvin. Similarly, when after 0 degree centigrade, mm, there is a conversion of ice into water, so it will be the latent heat of fusion, and this is calculated through this formula, and it becomes 3350 kilojoule per Kelvin. Then again, after the full conversion of water, the temperature of water is increased to 10 degrees centigrade, um, which is again a sensible heat, and is calculated by using the 10 kg by using this formula, and which comes equal to 41.8 kilojoules per Kelvin. So the heat required to change the temperature from -5 degrees centigrade to 10 degrees centigrade for 24 hours is equal to addition of this, which is Q1 plus Q2 plus Q3, which is equivalent to 97 plus 3350 plus 41.8 divided by 24, because the whole process occurred within a 24 hours. So this will become 3488.8 divided by 24, and here the 3488.8 is converted into kilowatt hour, and it becomes 0.976, and because the final results which we have to get is in kilowatt, so kilojoule is converted into kilowatt. So our answer is 0.040 kilowatt. uh, as we know, 1 kilojoule is 0.00028 kilowatt. So again we can convert this kilowatt into TR, because 1 TR is equivalent to 3.5, so I have divided this kilowatt by 3.5, and the answer is 0.012 TR, ton of refrigeration. Hope you understand. Thank you.